So how do we go back the other way then? Now, at this stage, we can't integrate log functions. In extension 2, we'll see a technique which will allow us to do it. Okay? But basically, we'll go backwards. So if we just differentiated and got derivative on function, then logically, if we integrate derivative on function, we must get a logarithm. So that's what we're talking about. If we can set up our integral so that the top of the fraction is the derivative of the bottom of the fraction, then we know the answer will be the log of the bottom of the fraction. So let's have a look. 1 on 7 minus 3x. Now, how do I know this is a log situation? If I didn't realize it, at this stage, what technique would I use? I'd need to put it into index form. And I'd say 7 minus 3x all to the power of -1. But then how do we integrate that? Add 1 to the power over the power. Well, add 1 to -1. What do you get?
0.
Thank you. So therefore, you're going to the power of 0 over 0. But you can't have 0 on the bottom of a fraction. So if you do that situation, you add 1 to the power over the power, and you go, oh, 0 on the bottom, that should be a little signal. Oh, hang on a sec. Something else is happening here. This is probably a log situation. I want to try a different method. Okay? Let's create the derivative on the top. Well, 7 minus 3x. The derivative of 7 minus 3x? Minus 3. So I'll make the top minus 3, but to balance it out, I've got to multiply by -1/3. But now, in my integral, I have derivative on function. So now that'll be -1/3 log 7 minus 3x. Plus, of course, a constant. dx on 8x plus 5. Because sometimes we like to be tricky, and instead of putting dx after the fraction, we put it on the top of the fraction. No, pretty tricky, hey? We want to still work out the derivative of 8x plus 5. So let's put 8 on the top, but to balance it out, I need an 8th out the front. But now I have derivative on function, log of 8x plus 5. Oh, hang on, wait. X to the power of 6 minus 2 on the bottom. What's the derivative of x to the power of 6 minus 2? I've only got 1x to the power of 5. What should I do?
Multiply the top by 6 and then you put a 6 out the front.
Sounds like a plan. Okay, so we've got 1/6, 6x to the power of 5 on x to the power of 6 minus 2. We have derivative on function, 1/6 the log of x to the power of 6 minus 2. 1 on 5x. 1 on 5 with 5 on 5x. So it becomes 1/5 the log of 5x. But now, watch this. This is amazing. Or, what if I factorise the 5th out of the integral symbol? I'm allowed to do that. I can factorise constant. What's the integral of 1 on x?
Log x plus c.
2 different answers. And yet, they're the same. Yes. Why? How will it be different? You are right, the constants are different constants. What do they differ by? Ooh, on the right track? 1/5 log of 5. Because, remember, log laws, log of 5x you could rewrite as log of 5 plus the log of x. Well, log of 5 is a constant. And so it's just that the two constants are different. So they are, in fact, the same answer. This is what makes marking these sorts of questions so much fun. Because I might be expecting, say, the first answer. You might give me the second answer. I've got to go, ooh, hang on a sec. Is that the same? And that, so, but you might also find that when you're doing questions. So you'll go to the back of the book to confirm your answer and go, oh, I didn't get that. And you might think you're wrong, but you're not necessarily wrong. You might just have a different way of writing the same answer. 4x plus 1 on 2x plus 1. How do I turn 4x plus 1 into the derivative of 2x plus 1? Well, what is the derivative of 2x plus 1? So how on earth could I turn 4x plus 1 into 2? Remember, we can't factorise out the x. If you get a situation where it's a polynomial on a polynomial, basically, in this case, they're both linear functions. But you notice the order of the numerator is the same or bigger than the denominator. In this case, they're the same. Then before you integrate, do a polynomial division and break the fraction up. Because that will become, well, if you had to do the division, there's the working out, but it would become 2 minus 1 on 2x plus 1. Similar to what we did when we were looking at those graphs where we had polynomial and polynomial and we broke it up. So now I've got something I can handle because we know how to integrate 2. What do you get when you integrate 2? 2x. So we can do that. But then the second one now is I just have to create derivative on function. So I'd end up with the 2x, but minus a half the log of 2x plus 1. Okay. So you see that order of the polynomial. If it's the same or more, do a division first, and that should sort out your problem. Let's do a definite one. The derivative of x squared plus 1 is... Oh, how lucky are we? Look what's on the top of the fraction. 2x. So that'll just integrate to be the log of x squared plus 1. Substitute the 2 in, substitute the 1 in. Log 5 minus log 2, which is, of course, log... I'm so glad no one said 3. Okay. 5 on 2. Here's one of these ones. You remember when we looked at those integration by substitution and they phrased the question, differentiate this, hence go integrate this. It was like a clue. Similar one here. Differentiate x cubed log x and hence integrate x squared log x. All right, differentiate x cubed log x. Write down the first, x cubed. Diff the second. The second is log x. Differentiate log. Derivative on function. 1 on x. Plus, write down the second, log x. Diff the first, 3x squared. So now we tidy that up. X cubed times 1 on x is x squared. So I now know that when I differentiate x cubed log x, I get x squared plus 3x squared log x. Therefore, when I integrate x squared plus 3x squared log x, I'll get x cubed log x. Well, I just want the integral of x squared log x. But we've got a rule that says that integral, I can break it up into 2 separate integrals. So I'm going to break it up and move the other one to the other side. And so I'll get 3 lots of, I've factorised the 3 out, I'm allowed to do that, can factorise constants. 3 times the integral of x squared log x is x cubed log x minus the integral of x squared. And the integral of x squared is, of course, x cubed on 3. And then divide both sides by 3. And there's our answer. 1/3 x cubed log x minus 1/9 x cubed plus, of course, a constant. 12D. 12E.